Right, so now after the model has been trained, I attempted to train it again, but this is the final result here. It took a long time. Yeah. So here, this is the result. So from the insights that we get, it took around 40 minutes to train this model. It's not bad. It's not bad given the resources and given the size of the data set. So a good time for it to be trained. And the size is not big. And so later on, we'll look into the optimization and deployment as well. So this is one of the important metrics that we'll look into to tell us the accuracy of our model. So given this, and I would say it's a good percentage because I believe that we need more images to make it more accurate. That's one. Two, to have more pre-processing steps could also help with the accuracy of this, and I will discuss that later on. And these are the other numbers, not very different. But yes, of course, there is room for improvement. And as I mentioned, one of them is the increasing of the data set. The other would be the extra steps for pre-processing. One of the steps that I would suggest is edge detection, okay? So let's take one of the images as an example. So here, we have something in the background. Let's say at some point the model will confuse this as the box. You can see here one of the objects that we have is a box. So if it was confused by something in the background, then this will also hinder its accuracy. And so edge detection would do this to detect the edges, one of the things, and also to separate the background. And also, if it did the edge detection, it will help the model detect the objects on the image way better than just it trying to figure it out. Yeah, so that's one. Okay, so next we want to apply these augmentation techniques to improve the model. Okay, so this was done very quickly. I didn't do it for all of them because it would be time consuming to do it all over again. But it did improve the accuracy a bit, and we'll see the difference later on when we're doing the testing. Okay, right, so now let's go to the testing. Copying the latest model from Drive. Right, so as I mentioned, it kept disconnecting, and so it was important to upload everything here and then download it again. And so after ensuring that we have it here, I went ahead and installed this library, and this will help me to train, test, and export the model. And also this, so that I can open, edit, and save images. Right, so I noticed the images that we had for the testing had a different type of format. And so this was the format before, and then we converted it to GPG, right? So after they were converted, that way I was able to use it for testing. Right, so now we want to test the model. The interesting thing about testing, right? Usually in the data that we have, we can divide it into three parts. One would be for training, which is what we did, training. I can show you a quick example here. This one, YOLO dataset. Yeah, so we did divide them into two. So for training and validation, 80% went for training and 20% went for validation. We can also have more, like a different category would be testing. And that would be some of the data that we are using for the training, but the model will never see it, okay? And so we will use that to test, to have more variation for the testing as well, because now we're only using 4 images to test, okay? But it's okay. And that will also give us some insights. And let's see. Okay, so here are the results. 2 of the images were were successful when it comes to detecting the images, I mean the objects in them, but 2 of them were not, okay? So the reason behind that is because these images are very dark. The brightness is very dark. So this is very different from the images that we used for the training. Yeah. So this is why it's important to have more variation of images and to do even more pre-processing steps to help the model be able to detect cases like this. Yeah. But the good news is that the ones that it actually detected are all accurate. So that's good. So at least the performance of the ones that it detected are good. So we can take a look at the results here. I did visualize them actually here. Let's see. This is the other code, the messy one. Yeah. So it was able to detect these three. And here, these are the dark ones. Yeah, it wasn't able to detect those. But here we have another one. Let's see. Detection results. This was the best performing one. It detected all of them correctly, as you can see. So that's also good. Yeah. Okay. So after the testing, make sure to save everything to Drive. It's a very important step. Yes. So then we want to measure these. These are the metrics that we use to understand the accuracy of our model, right? So here are the results. And we can see, we can just copy this to the results we had earlier here so that we can compare. And the reason why I'm comparing is because these are after we did the fine tuning, right? So it's a bit like the augmentation techniques. So the accuracy increased just a little and the recall decreased just a little, but the other metrics have improved really nicely. And so, of course, the more we make changes, maybe the better the results will be. So that is really, really interesting. Okay. So now, visualizing the results as I showed here. Yes, it detected 2 of the images. Okay, so the last step is optimization and deployment so that we are able to use our model not just here in Colab, but if we want to export it and use it in some other project, now we can use this format. So after we converted it, we evaluated it using validation data, and then we ran it using the images, and then we visualize the results. My bad. These last results that I showed earlier, these are the results of this code. Yep. Okay. Awesome. And then I saved the model back to my Drive. And to show you what this is, like this format is, we can actually see it here after we deployed it, or actually uploaded it to Neutron. So yeah, this is the model. A visual way of looking into it. It's really interesting. So now it's deployed. You can use it other projects, but of course, it would be better to improve the accuracy and to train it using different data and to do more fine tuning and more adjustment. Perhaps use a different model so that we compare different results. Maybe a different model will be able to detect these types of objects in these different conditions and different angles. But that needs more time and resources, especially with images. It needs a lot of what is it called? GPU and RAM, and needs a lot of memory to be able to train. But the concept is there, and it's really, really interesting, as I mentioned. Thank you so much for tuning in to my presentation. I hope it was all very insightful and clear. And thank you. Goodbye.